Okay, so tonight our video is about the new packet that you received today that's kind of, I guess like an insert into our Unit 8 packet, because we changed up the order that we're teaching some lessons, so you'll be better prepared for your test next week. So I need you to have this packet open and be on this first page. We're going to be talking about quadratic transformations. So this graph right here, this line right here, this parabola, is what we call the quadratic parent function, okay? And it's represented by just y equals x squared or f of x equals x squared. You know that f of x is the same thing as y equals. So x squared is our parent function. No plus, no minus, no other x's, nothing, just x squared. Positive x squared. And that's what we call the standard function. You can see the vertex is here at 0, 0 at the origin, and it's positive. The axis of symmetry goes right down the middle, right there on the y-axis. Alright, so let's talk about what happens when these parabolas, when you see an equation and you can determine what the parabola is going to do based on the equation when comparing it to the parent function. Without even graphing it, you could tell what it's going to do. So the first type of transformation is that it will shift up, and it's a vertical shift up. A vertical shift up. So in this example, we have our parent function, x squared, and it's graphed right here. And the directions say transform f of x or y equals by adding 5 to the output, and we're going to call that g of x. Okay, so don't worry about f of x and g of x. Just go with me. Okay, we're going to graph and label g of x equals f of x plus 5. All right, so that g of x is just the parent function plus 5. So let's go ahead and take out our calculator. Remember, if you're at home and you want to do this on your phone, you can download the Calculator 84 app, and you should be able to see everything that's happening here. So what I'm going to do first is I'm going to put in the x squared parent function. And then on the next y2, I'm going to put in x squared plus 5. Okay, so we'll have the blue line is the parent function, and the red line will be the parent function plus 5. So let's go ahead and graph those. Okay, so you can see here, it's the same parabola. It is just moved up or shifted up 5 so that now it's going through the y-intercept at 5. So what happened? There was a vertical, it moved up, a vertical shift up 5. Okay? All right, so let's do this again. We're going to go back to y of x. We're going to keep that x squared as our parent function so we can have it there to compare. Oh, we forgot to draw this. I'm sorry. So now, instead of the vertex, let's go back to the top one. Let's get, instead of the vertex being at 0, 0, it's going to be at 5 because that's now where it crosses. And now it's moving up. That's a terrible drawing. Don't look at this line. Okay, but it's just a sketch. Okay, all right, let's go down here. So now we're going to do, instead of just x squared plus 5, we're going to do x squared. We're going to shift it up 7 now. So in your head, I want you to kind of think about what is going to happen to that line. Is it going to go down more, or is it going to go up even more than last time? Well, let's take a look. So there's your parent function, and there is the second one that was plus 7. So what it did was it moved up the y-axis 7 instead of just 5. It was a vertical shift up 7 places. So over here, instead of our origin being at 0, 0, the parent function, since it's plus 7, x squared, regular x squared plus 7, it's now going through at 7. Okay? Alright, let's go to the next page. We have a vertical shift down. This is where you're going to see subtraction. It's going down. So we're going to start with our parent function, x squared. And this time it wants us to go down 3. Down 3. So what do you think is going to happen to that line? Instead of it going up now, it should, the whole parabola should be going through, yes, down 3. So what has happened to f of x? It was a vertical shift down 3. So now it's down here at negative 3. There it is. Okay. All right, let's do another one. This time we're going to have a minus 8. X squared minus 8. All right. So let's go ahead and predict. What do you think is going to happen? Where is it going to cross the y-axis? Well, I'm predicting it's probably going to cross here at 8 because it's moving down 8 this time. And let's see if we're right. There's your parent function. Whoop, there it is. And it is at 1, 2, 3, 4, 5, 6, 7, 8. So we had a vertical shift down 8 because it was subtraction, minus 8. Okay, so let's talk about what happens if there is a horizontal shift. How can we get this parent line to go to the left or the right? Okay, so horizontal shift now. So let's go ahead and go back to our y equals. I'm going to clear out that second y equals and leave my parent function in there just to compare it with. And this time, we're going to say it's we have these in parentheses here, and so it's f of x plus 5. All right, f of x plus 5. So you can't just say that x is now inside the parentheses. The plus 5 is. It's inside the parentheses. So you'll transform f of x by adding 5 to the input, and we're going to call it g of x. Graph and label g of x. Okay, so let's see what happens here. In our calculator, we're going to input this as, we have our parent function x squared. We're going to compare that to x plus 5 to the second power. So here's the reason why that plus 5 is inside the parentheses. Because it's inside the parentheses here. Okay, so it's x plus 5 squared. You still have that parent function, x squared, but now that plus 5 is inside. So let's see what happens when we graph it. There's your parent, and there's the new one. Okay, it's shifted it over to the left 5 spaces. Okay, so now instead of our origin being here at 0, it's now at x is negative 5. So this one's a little bit more tricky because even though it says plus here, it went to the left. It went to the negative. It subtracted. So there was a horizontal shift to the left 5 places. So why did it go to the left if there was a plus sign? Well, when you put those parentheses in there, it's like those parentheses made it do the opposite. All right, it kind of flipped it. It made it go from plus to minus, so that's why it moved it to the left, to the negative side. All right, let's do another one. Up here we have adding 2 to the input, and we're going to call it g of x. So in your calculator, it would be y equals x plus 2 squared, because it's your parent function is x squared. So you have to add that 2 to the x before you square it on this one. So now I have x plus 2 squared. And what do you think is going to happen? Do you think it's going to shift to the left or the right? And how many spaces? Well, let's see. There's your parent. Oh, there we are. It went to the left, but this time it only went 2 spaces because that's how. All right, so it went a horizontal shift to the left, two. Okay? All right, let's look at this next one. This time, looks like we might be going to the right. Okay? Because look, we are subtracting here. Remember when you have those parentheses, it makes it do the opposite. So instead of going to the negative side, it's going to do the opposite. It should go to the positive side, to the right. So let's go to y equals. Keep your parent function in as the control, the top. And we're going to now put x plus or x minus 3 instead of x plus 2. And let's graph it. Parent, new function. It did. It went over 3 spaces. It had a horizontal shift to the right 3 spaces. Okay, so let's look at number 8. This time we're going to subtract 2 from the input. So now we're still subtracting here, but now it's 2. So y equals, and now we're going to use x minus 2. We're going to graph that. There's the parent. There's the new one. Now it's shifted to the right 2. Okay, a horizontal shift to right 2. 2 places. Okay? All right. So the next page. Okay, so let's talk about what happens when you have a vertical stretch. A vertical stretch. That is now, instead of just going up or down, it's going to do both. It's going to go up and down at the same time. So your a has to be greater than 1. That's key. All right, and the a is what's multiplied by your f of x, your parent function. So let's go back to our calculator. Your a is multiplied by the parent function. A multiplied by your parent function. That's what f of x is. So it says multiply it by 3. So you're going to have y equals 3x squared in the calculator. That's how you're going to put it. So let's see here. 3x squared. Oops. Parent. Ooh, it got skinnier. Okay, so it's skinnier now. It didn't change the vertex. The vertex is still that E0, 0, the origin, but it made it skinnier. There was a vertical stretch, and it got more narrow. Your number, let's make a note here, your number that you multiplied it by was greater than 1. So that's what we have to check for. Let's look at the next one. We're going to now transform by multiplying the output times 2. So now it's going to be y equals 2x squared. So let's see, do you think it's going to get more narrow or less narrow? Let's see. Parent? Oh, it got wider. It got wider. Okay, so vertical stretch. Well, it was more narrow than the parent function, but not as narrow as the last example. It's still narrow. It's more narrow than the parent function, but not as narrow as that 3 was at the top. Okay, let's look at vertical compression. Vertical compression. This is where you're multiplying a number times your parent function, x squared. But a is going to be less than 1. A is less than 1. Okay, it's still going to be a whole number, but it's less than 1. So we're going to have some fractions. So let's go ahead and put that in. I want you to remember this. Fraction, flatten. Fractions flatten. Okay, so let's put this in here. 1 divided by 2. X squared. Okay, so 1/2 x squared. All right, you make sure you put your parentheses around that 1/2 so that that fraction stays together. We're going to graph it. There's your parent. Ooh, it's getting wider because it's starting to flatten that parabola. It's making it more flat. So it's going to get, it's a vertical compression. This is a vertical compression instead of a stretch. It's a vertical compression. It's going to get wider. The smaller the number, if the number is less than 1, it's going to be wide. Okay. You also could, instead of just fractions flatten, I think it makes more sense if you say the fractions fatten. It makes it fatter. It makes it wider. Okay. All right. Look at this page right here. This is, just to save you some time here, since it's 1/4, it's going to be even wider because that number is getting smaller. It's going to be wider. And look at the horizontal compression. We've looked at vertical compression, so let's look at the horizontal compression. We have our parent function, x squared, and now, since we're multiplying inside the parentheses, we're going to multiply 5x, parentheses, 5x, oh man, x, okay, like this. And we're going to see what happens because now this 5 is inside the parentheses. So let's see, graph. Parent, ooh, got super narrow. Now it's like this, right? Okay, so let's see what happens when it becomes 2. When it's not just 5x, we're doing y equals 2x squared. Okay, let's see what happens when we change that 5 to a 2. Okay, it's not as narrow. The greater the number inside the parentheses, it's narrow, but it's not as narrow. It compressed, but not as narrow. Okay, all right, let's go along. Horizontal stretch. This is where we're going to stop for today, and we're going to finish this on Friday in class. Okay? All right, y'all have a good evening.